Okay, things we need to do for homework 1 are look at the description of some kind of a triangle, and you have to read through that description carefully so you don't miss any important information. We have lengths of 3, 4, and 5. Angle C is a right angle, so we're dealing in a right triangle. Angle A is smaller than angle B, and our job is to find sine of angle A, cosine of A, and tangent of angle A. Well, we'll begin by drawing a rough sketch of a right triangle. Mark off your right angle on the right triangle, and it says that the angle C is the right angle, so we'll label that there. We have lengths of 3, 4, and 5. Hypotenuse has to be 5, it's the longest side. And then it says that angle A is smaller than angle B. Well, that must mean that we have to put the 3 opposite angle A because it's the smaller of the two sides. Leaves a 4 for here. Now our job is to find sine, cosine, and tangent of angle A. Well, here's angle A. I'm going to color in that wedge. And if you have to find sine of angle A, and you should always say sine of something, put an argument in between those parentheses. Sine of angle A, we know it's equal to the opposite side over the hypotenuse. The hypotenuse is 5. Well, the opposite, if you have your finger on the red wedge, opposite your finger would be the 3. Moving on to the cosine of A. We know that it's adjacent over hypotenuse. The hypotenuse is still 5, and we're going to think about our finger on top of that red wedge, and our finger would be touching the 4. And touching means adjacent, so we'll put the 4 as the adjacent side on top of cosine of A. And then I'm going to show you a slightly different way of calculating the tangent of A. Instead of thinking of tangent as opposite over adjacent, we could also think of it as the sine over the cosine, but we already have a number for the sine and we already have a number for the cosine. When you divide these two fractions with the same denominator, the denominators cancel out. The tangent is equal to 3/4. And if you don't like that method, you can go back to the opposite over adjacent, 3/4. But this will come in handy later when we start working with special angles. So you'll have to read carefully through the descriptions of the triangles. They keep changing, and there's a little bit of a trick to the one where they ask you about the 30-degree angle. You have to think about that for a moment. Next section, you'll be asked to draw angles in standard position and then name the quadrant that they're in. Well, standard position means we always start at 0, and if it's a positive degree measure, we'll go up. If it's a negative degree measure, we'll go down. So let's take a look at the 30-degree angle. The 30-degree angle, I'm going to start at 0. It's positive, so I'm going up approximately 30 degrees. I'll sketch that angle there. That tells me I'm in quadrant 1, and I'm done with that one. Moving on to, I'm going to erase that now. Moving on to the 200-degree angle, I'm going to start at 0. It's a positive number, so I'm going to go up. I'm going to go 0. I'm going to go past 90. I'm going to go past 180. And then I need to go about another 20, and then I'll stop, and then it'll be time to put my ray in there. And I'll label that theta is equal to 200 degrees. We're going to be using the variable theta. It's a Greek letter. So we end up for here in quadrant 3. If I have a number that's bigger than the first circle, well, I'm going to do the same thing. 400 is a positive number, so I'm going to begin by going up from 0. I'm going to be counting off as I go. I've got 90 degrees, 180, 270, 360, and then I need to go another 40. So now I'm at the point where I can stop. I'm going to draw the ray there. And this arc would be shown, it's an arc of 400 degrees, so theta is equal to a 400-degree angle, and we end up in quadrant 1 again. What changes if I have a minus sign in front of the degree measure? Well, if I have a minus sign in front of the degree measure, instead of starting by going up, I'm going to start by going down. So we'll start here, and I'm going to go down 80 degrees, and I don't quite make it to the 90 mark. Draw in my arrow. This angle here, theta, is equal to negative 80 degrees, and I'm in quadrant 4. And the last example for this section, I've got a negative 300 degrees, so I will start at 0. Since it's negative, I'm going to go down first. I've gone down 90, gone down 180, gone 270, and then I need to go another 30 degrees or so, and I'll draw my angle in there. This angle is equal to negative 300 degrees, and so we end up in quadrant 1. And moving on down to the last section, find a coterminal angle with a measure of theta. Again, and I just want to spell that out for you. It's TH. Theta is how it's pronounced. It's a Greek letter. It's just a variable, just like x is a variable, but the Greeks were the ones who invented trig, so they get to use their own alphabet. Find a coterminal angle with a measure of theta. Now, this is an important instruction. It says you can use any answer from 0 all the way up to 359.99999, but you cannot use 360. Oops, I lied on that one. That actually does include that. I'm thinking of another set of instructions that doesn't use that. So we can use any answer in between 0 and 360. However, 0 degrees and 360 degrees would be the exact same place on our graph. Okay, I'm going to show you two ways to do this one. Just watch while I show you the first way. 412 degrees. Well, I could do what I did before. I could start at 0, and 412 means positive, so I'd go up 90, past 180, to 270, to 360. I've got to go another 40 and then another 12, and so I'd be stopping right there. But there's actually an easier way to do these. Instead of you going around and around, because you can't spin your, we don't need to see those loops forever, and you can't spin your arrow like I can. So instead we're going to work this way. If we see a number that's a lot bigger than 360, we're going to start subtracting entire circles from that number. And so if you subtract an entire circle, here we get 52 degrees. And as soon as you have an answer that's in between these red instructions, then you can stop subtracting. If I look at this one, 540, I've got I'm bigger than the first circle, bigger than 360 degrees. So again, I'll subtract out whole circles until I get in between my instructions here, 0 and 360. So if we subtracted whole circles when I started out with positive numbers, then if you see a negative number, you can begin by adding complete circles. And if I add 360 to negative 10, I get 350 degrees. Again, I'm within my limits here in the instructions, so I'm good to go. This one, it's a negative number. I'll add 360 degrees, and that gives me 90 degrees. Again, I'm within my limits, so I'm good to go. But watch it. You might have to subtract a couple of circles. You might have to add a couple of circles. And one complete circle is 360 degrees. Now I'm going to go back and talk about the things that you are already supposed to know and the things that you really should understand in order to be successful going forward. So let's take a look at the nose slide. Well, standard position, that's where we actually drew the graph, and then we would mark out by virtue of the arc how far we were going, and we would determine that quadrant. In coterminal, if you have coterminal angles, I'm going to jump back to those instructions for the last parts we did. It said find coterminal angles. That's what we were doing. If you just keep adding and subtracting whole circles, you will end up with coterminal angles. They're coterminal when they're angles that end on at the exact same place on the coordinate plane. All of this here, you can pause the video if you'd like to take a look at it, but that's things you should already know and things that will come into play as you work with the triangle descriptions. Moving on to the understand page. And this is pretty important. As we do our functions unit, I'm going to show you the bottom of this page first. On the bottom of this page, you're going to see the way that you first learn trig. You learn sine, cosine, and tangent as 3 words, and they had equivalent fractions with words in them, but they're not words, they're actually functions. So I want you to think of the sine, the cosine, and the tangent like this instead of like this. And so that means that we put in some x value into what we call the argument of the function, and we get some y value out of it. If we were to look at an xy axis, as I have up top here, if you have xy axes, then your x values are these numbers you're putting in right here, and the y values are numbers you're getting on the axis. The important thing to note about the x-axis when you're dealing with trig is that the x-axis contains the angles and the y-axis contains just numbers. We call those numbers function values, just like we did in the functions unit. So trig functions, you can get function values for trig functions, but the input to the trig function, the argument, we call it the argument of the trig function, has to be an angle. The units that we've used so far are in degrees.